Hello everyone. We are Team 31, and today we are excited to present our language which we have created, which is FoodLang, a fun food themed programming language we designed for us for simplifying ourselves. Uh, this is a project which we have chosen for SER 502 Languages and Programming Paradigms by Dr. Ajay Bansal, who has been a guide throughout this course. You all can find the GitHub repo link over here in the first slide. Uh, I'll now introduce my team. The team members are Dikshant, Hitesh, Archie's, and myself, Arvind. So why did we choose Foodland? So we chose Foodland to design or demonstrate that programming language can be made more engaging and simpler, especially for beginners. Our idea was to lower the learning curves by using familiar, playful terminologies from the kitchen to represent core programming constructions. Ultimately, Foodlang proves that serious computing concepts can be taught and demonstrated in a playful, memorable way. Highlights like plate for integers, serve as a print statement, and kitchen as an entry point explains you more about our kitchen language, which is Foodlang. So to take you more towards this programming language, I would request Dikshant to tell you more about the basics of FoodLang. Thank you.
So thank you, Avent. So hello everyone. This is Dikshant this side, and I will explain few things about FoodLang. So FoodLang is basically a fun language that has uses the structures of C and C++ with a flavorful culinary twist. It is statistically typed and interpreted language built in Python, which is always like as a food inspiring language, and it uses food inspiring terms like based on associated with utensils to represent the traditional programming concepts. So whether if you are declaring a language such as like a variable like a plate or print output with a serve, food lang will give you a feeling of like cooking. So it is like creative and little bit delicious. So the purpose of this language that we are keeping in mind is to like make this language more relatable and engaging using the kitchen concepts. So moving on. So this is our design goals that we have like kept in mind before starting our designing our language. So the first is readability. So we thought about keeping this language as human friendly as possible, and basically it is for foodies. And the second point is like keywords and constructs. So keyword is like basically it is like engaging. So if a user has to feel like creating a food, so it starts with using going to a kitchen, which is the entry point of our program, and uses plate and ball for integer or float, and then ham for strings and serve as a print option, and many more can are explained in the further slides. And the last point is simplicity. Simplicity, like we try using different like simple terms and provide a steep learning curve throughout our presentations. So moving on to the next, this is the grammar of our code. So grammar is basically starting with the programming block. The programming statement is like starting with kitchen, which is like a main function of our program, which is the entry point. And then beside that, we are providing like a block statement. A block statement is nothing but it contains a list of different statements that are given below. So statement list is basically just like declarative statements, assignment statements, print statements, if, while, for. So these are the particular declare statement list that we are like giving into our block statement so that it can compile the program. Declaration statement is nothing but uh, like where we are defining the types of the particular variable, such as like plate for integer. And then for the assignment operator, we are using equals to operations and like given the expressions of it. For print, we are using serve as we have as I said before. Next slide, please. So in this if statement, we are using the terms like eat, which is also like taking an expression as an input, and like if it is uh, getting the term correct, and then it will give you the block. And then after that, we are using the else statement. And apart from that, we are using while statement, which is the repeat order. And for statement, we are using combos. Apart from that, we are also using conditional expressions like logical expressions, which is like a question mark and colon, which is for the ternary operators. And then we have defined some logical or and operations as well. Apart from that, we are also using equality expressions like double equals to and not equals to. And then we are using the relational operators, which is the additional operators and like additive operators, multiplicative, division, subtraction. We are using that as well. And we are also using unary operators, which is like not and which is the number, and primary expressions as well we are using. Next slide, please. Uh, Primary expressions, we are using Boolean expressions like check, and which is shown in the next slide. And types are played, bowl, ham, check, that I have already mentioned before. And Booleans are true and false. So this is the key feature of our language, with the premeditated type, plate, and ball for numeric values. And then we are using ham for string and check for boolean. Apart from that, we are using operators such as arithmetic, regional, and assignments. Ternary operator also we are using that with the question mark and colon, as given before. Question mark is for true, and colon is for like. Apart from that, the second statement that is after ternary operator is false. And then we are using control statements such as kitchen, which is the entry point that I've explained before, which is the main function. And if and full, so eat and full for conditional blocks such as if and else, combo for loop, repeat order for while loop, and serve as the printing output, taste for try, spit for catch, leave table for break, skip, byte for continue, logarithmic functions we are using log, and for power function we are using pow. So for further explanation of that particular things, I'm giving the platform to Archie's. Thank you so much.
Hello, Archie's.
Hello.
Yeah, you can continue with additional function.
Yeah. Hi, everyone. This is Archis. Let me start by talking about how we are making the FoodLang experience more enjoyable and accessible, especially for new programmers. To enhance usability, we have built a custom Visual Studio Code extension that adds syntax highlighting for .fd files. After installing FoodLang syntax v6 file by processing Ctrl-Shift-P and choosing extensions installed from V6, developers instantly see their code highlighted with color-coded syntax. This makes a big difference. Keywords like plate, serve, and eat are highlighted differently from strings, numbers, and comments. That improves code readability, reduces errors, and makes the experience more beginner-friendly. Currently, the extensor covers basic syntax. We are actively developing it further. Future updates will support newer features like taste and spit for try-catch handling, leaf table and skip byte for break and continue, and built-in functions like log and power. It's a small but powerful enhancement that makes working in FoodLang more intuitive and fun, especially if you're exploring it for the first time. Next slide, please. Now that we have covered the tooling support, let's look at how FoodLang code actually runs under the hood. Here is a simplified execution flow. We'll begin with the .fd source code. This is basically our raw FoodLang program written using its playful and readable syntax. The code then goes to the tokenizer, which reads the file and breaks it down into tokens. These are individual elements like keywords, identifiers, numbers, and so on. The tokens are then passed to the parser, The parser organizes these tokens into an abstract syntax tree, or AST, which is essentially a structured map of how the code is meant to execute. Next, the interpreter works through the AST and performs the actual logic defined in the code, executing statements, running calculations, and managing flow control. Finally, the result is displayed in the console output, whether it's a printed message, a calculated value, or just confirmation that code ran successfully. That's where the output shows up. So from writing .fd code to tokenizing, parsing, interpreting, and outputting, this flow ensures that FoodLang remains both simple to use and educational for those learning how interpreters and compilers work. Next slide. I would ask Hitesh to continue.
Hello. So I will walk you through the tokenizer and the following. So the tokenizer is essentially, it'll go through our code and it'll break it into tokens using regex operations, and it'll identify the tokens like kitchen, the parenthesis, the assign, and etc. The parser will basically parse through the code and identify the logic. This is the sample parser code that we have and the output AST that we generate. And then the runner and the interpreter. So basically we call the interpreter, and which in turn calls the runtime, and then our program is executed, where we'll find the output on the console. So this is our sample code. This is the arithmetic function where we have a plate that is assigned integer, and then we're doing a bunch of arithmetic operations, and then using serve to print the final result. And then this is a different basic function where we are showing strings and the other data types that we have, like for example bool for float, and then ham for strings. And then we also have multi-line strings available within our program, where we're doing it with the ham story. Similarly for loop, where we have kitchen as the entry point, and then combo is our for loop. It goes between 1 to 5, and then displays the output. And similarly for if else, where eat is the if and full is the else. And ternary operators, where the question mark, where the question mark, the statement, and the true statement and the false statement. And then the while loop is with repeat order, where depending on the evaluated function, it will run the while loop. So we have break and continue here, where we are using try, eat, and break and continue. Oh, sorry, break and continue was this, and then try and catch is taste and spit. Okay. Before this, I'll just show you the output of me running the code. And so this is the sample program that I've written to show how our program will be executed. And for simplicity, we have added a bat file for Windows and an executable for Mac. And we can use the following command. We can use foodlang followed by the name of the file, and simply executes the program. So here I have executed a bunch of statements going from each of the functions that I had just shown you. And as you can see, it is all correctly displayed right in front. Then moving on to the future scopes, in the future we want to be able to include arithmetic operations and adding concatenation in the serve statement, which is not currently supported. And we want to support functions and modularization, where we want to introduce user-defined functions, example recipe. This is what we've thought about, and then modular file imports, example serve from pickle rack.fd. and a domain specific extensions like creations like baking lang or cocktail lang to simulate recipes, recipe automation, IoT kitchen device control, or gamified cooking lessons. That's all for our presentation. I thank each and every one of my teammates who were here to do the project with me. It was a great experience. Thank you.